Welcome to Off Hours, a conversation between John Edwards and Chris Manning.
So we have a special guest joining us here on the show today. Apart from a handful of independent watchmakers, he's probably one of the names that has been most dropped on the show here, and it is machinist Paul Burberry. Welcome to the show.
Thank you.
Yeah, Paul has been a good friend for years. We met at the Ottawa Fountain Pen Society here in Ottawa. He showed up one day and was silly enough to announce himself as a machinist at Ottawa U. And so we then struck up a conversation and started talking about machining and various problems that I was having and how to correct things and whatnot. And over the years, he's become my mostly tame machinist who I use when I have problems or I don't understand how to do something. He's my go-to guy for helping me out with figuring things out.
And he's certainly helped with all manner of things over the years and making your tools better and more adapted to the stuff you're working on.
Yeah, as I like to say, it's good to have low friends in high places, and he has a wire EDM or access to a wire EDM, so that puts him into a high place in my books.
Well, but before we dive into the rabbit hole of machining talk and pens and pen making that I'm sure we'll dive down eventually, how about for the sake of our listeners, get a bit of background on you, Paul. So where did you grow up?
So I grew up in a little village just on the outskirts of Sheffield called Swallownest. And it was had about 5,000 to 6,000 people in there. And, it was a lovely little spot. It used to be anyway, not so much now. But for anybody that doesn't know too much about that area, it was kind of sandwiched between a large city called Rotherham and a pit town called Orgreave. So a lot of people that lived in Swallownest either worked in Rotherham or they worked in the Sheffield steel mills or they went down the pit. It's actually a very, very old place. It was originally founded by a farmer called Farmer Swallow. And his original house is actually still standing there. And that house has got to be 700 or 800 years old now. That's where I grew up as a young lad. Lots of trees and open space and great big reservoir to go fishing in and all that. Very, very Dickensian style upbringing.
And at 700 to 800 years old, that house clearly wasn't here in Canada. So you're speaking to an area in the north of England.
Naturally, yeah. So Sheffield itself is located in South Yorkshire. South Yorkshire originally just, the entire county was split between 3 ridings. So you had North Yorkshire, East Riding of Yorkshire, and West Riding of Yorkshire. And then somewhere along the line, they split some of East and West Yorkshire into South Yorkshire. Once they put their own Metropolitan Borough Council in, it became its own borough, and Sheffield was in that borough.
So what was life like for you as a kid? Like what ended up drawing you to become a machinist?
Well, to be honest, lousy exam results when I did my GCSEs. I absolutely torched my GCSE results, so I'm a fairly uneducated sort, all things considered. I had 2 options. I either went to trade college, which I'd actually signed up for. I was going to be a bricklayer and plasterer. I ended up getting a job in a fabrication shop about a fortnight before going into the bricklaying college. So I took this fabrication job in a PVC plant and ended up becoming proficient with their CNC chopping equipment. So they had CNC profile saws, CNC routers, and I got really fascinated by, the machining aspect. So what we were doing there were European-style plastic window frames and door frames. Through that, I started advancing my machining career before ending up in a metal shop.
So you've been here now for a little over a decade, and you've done a fair bit of work in high precision environments, right? Like you've focused on, I guess, work that is sort of beyond what the average job is doing.
Yeah, absolutely. I've done. So I'll give you a quick run through of what I've done in Canada. I've worked in manufacturing for the healthcare industry, building transfer systems, support rails, things like that. And then I did a brief stint with a military subcontractor. By the way, if anybody ever says military precision, that's marketing nonsense made by Ford to flog your new truck. Military precision is basically if it fits and it's off by 1 division on a tape measure, that'll do. And then I got into the really high precision stuff. So we're talking temperature specific tolerancing,
Right.
surface finish tolerancing, running fits, heat shrink fits, all that stuff.
Currently, you're at the job shop at Ottawa University here in town. And what kind of work are you doing there? Because I imagine a university itself doesn't really have a lot of need for a machinist.
In U Ottawa, I work for the mechanical engineering department. So I'm actually involved in a lot of the research that goes on there for the engineering department. We do a lot of the experiment building, manufacturing, helping the students out with design, letting them know what can and cannot be machined. So we interface directly with the engineering students to ensure that they go out into the world knowing that you can't make a square-cornered hole with sharp corners.
Yeah, that's actually a good point, because a lot of engineering students, while they're learning a lot of the theoretical parts of what goes on in the world and material sciences, they don't necessarily know whether it can be built or not.
That's right. And this is one of the issues I find with SolidWorks. So we actually teach SolidWorks as part of the first year engineering course. And what that enables the students to do is they can envision parts and they can draw them, but then there's kind of a bit of disconnect between what can physically be manufactured versus what you can draw.
Sure.
Because you can draw just about anything in SolidWorks. You can get really elaborate organic shapes, which are ideal for the bane of my existence, the bloody 3D printer. But as for physically manufacturing something out of a material like aluminium, that's where we interface with the students to go through their designs and either help them simplify or tell them what physically cannot be done and offer insight and changes.
That certainly becomes problematic, and it's something that I've struggled with over the years, is trying to figure out, it's, I can create a design, but can I actually make it? And then on top of that, sometimes I can make it, but it's just not practical to make it, and that can be a bit challenging.
So what we do towards the end of the year is we invite the 4th year students in who are coming to the end of their formal education before they graduate. They come in and visit the machine shop, and they take a look at how a gear is cut and how a screw is made. And we actually put them hands-on with the machinery so they can cut their own gear and cut their own screw. And then as part of that, I've made a multi-CNC machine assembly, which basically makes a 2-pinion gearbox. So that allows me to demonstrate CNC machinery. So I have a high-speed Haas machine running a gearbox chassis out of aluminium. So it shows things like high-speed dynamic milling, even in-process measuring, probing, and adjustment.
Right, okay.
So they get to see a lot of the technology that's available. And then the lathe is usually making a integrated gear shaft and pinion gear, which will go into the 4th axis on the other mill, and it gets cut the same time the acrylic gearbox cover gets cut.
Okay.
So at the end of the lesson or the end of the lab, somebody gets to put their spur gears into the gearbox and complete a gearbox and go home with it.
Oh, right, okay.
That enables them to get a better understanding of, what machinery can do, which I like to think hopefully helps them become better designers.
Mm-hmm.
Yeah, it also helps to understand things like gear, especially with gears and screws and threads, that there are theoretical limits to what they can do, but there are also practical limits to what they can do. You can't make a perfect 100% engagement thread, for instance. If you try doing that, it's a V thread, it will never move. You might be able to get it together once, but you're never going to be able to get it back out again.
That's right. And what we try to do with that particular aspect of the lab is we show them the Bible. So for anyone not machining inclined, we refer to the Bible as the machinery's handbook. So this is the golden book that every machinist has that gives you absolutely anything you want to know about machining. And there's a bunch of really good pages on the unified screw thread. So it gives you thread profiles, what each part of a thread is called, and it shows you engagement and gives you ideal numbers for the correct 70% engagement threads. So in conjunction with that book, we make them calculate what the ideal thread should be, and then we give them a thread mic and they get to measure their own thread as they're cutting and do the final adjustments.
So a thread mic is not something I'm familiar with. What is a thread mic?
So it's like you've seen a standard micrometer,
Mm-hmm.
right?
Yeah.
So imagine you take the flat anvils off and you replace one with a V mic and one with a point. So you have two anvils, one top, one bottom, V on the bottom, point on top. And this measures the pitch diameter of a thread. So once you bring that pitch diameter within tolerance based on the machinery's handbook data, you will technically be able to thread that screw onto a nut.
Handy.
And if you don't happen to have a thread mic handy, you can still use a traditional mic. You just have to use thread wires, which is a pain because you have these 3 wires that you put in the grooves of your threads, and then you use your normal mic over top of it, and then there's a formula that you use for figuring out exactly what dimension you have using those wires. So there are ways of doing it if you don't happen to have the fancy tools.
Yeah, the classic three wire method was used before we got access to thread mics, and
yeah,
the biggest thing you can do with a 3-wire method is use an elastic band.
Yes, that certainly can make your life easier.
Elastic band really saves your life, except when you get to the really small ones where the elastic band just bends your wires around it.
Yeah.
So what are some of your favorite machines to work on there in the shop?
Well, at U-Ottawa, we purchased a Haas Super Mini Mill 2. The Haas Super Mini Mill 2 is I'm going to air quote high-speed spindle. It's only 10,000, but that's more than enough for everything you want to do.
Well, maybe everything you want to do.
Everything I want to do.
Barely moving for some of the stuff that I want to do.
Well, I mean, not everyone's got one needs a 50K spindle, right? So the Haas Super Mini Mill 2, it's a small footprint, high-speed machine, which is I find exceptionally useful for rapid stock removal. So when we got this machine, this actually put our turnaround times down significantly because it's a much more rigid machine than our tool room mill. Whereas before, with the tool room mill, I was roughing aluminium at around 100 inches a minute. I regularly rough aluminium at 300 to 400 inches a minute on the new one. And when we purchased it, we sprung for the WIPS system. So that's a workpiece probing system put together by Renishaw. And what this does, this enables you to cut setup times down significantly by not having to do all your tool touch-offs. You just assemble your tools, fill out the data fields in the offset page, and cycle it through the tool length presetter. A 10-tool job can be put together in under 15 minutes now.
Wow.
One of the things I've noticed in the last sort of 20 years is I've been learning more and more about machining, and I've certainly come at it from initially an amateur sort of hobbyist kind of point of view, and I've been slowly working into the professional side of it. It really is amazing to me just how much advancement there is in machining over the years. Even in the last 20 years, things like high-speed machining toolpaths and whatnot have really dramatically changed the way that we think about milling and machining. And stock removal now, the stock removal rates are just astronomical compared to what they were 20 years ago. And it's not as if we were building less rigid machines 20 years ago, but we really do understand it a lot better. And it is quite impressive, some of the new understanding that we have about machining, which you wouldn't think is a world that would change all that much.
So, yeah, I mean, even you're going back 20 years, but even in the last 5 years, things have changed incredibly with regards to stock removal rates. And like you say, a lot of it boils down to dynamic toolpathing. And what this does is it enables you to use more efficient toolpathing. It almost turns a CNC mill, which is, you would think traditionally as a slow-moving chugger, into basically a metal router.
Yeah.
How these toolpaths work is you can significantly increase your depth of cut by significantly decreasing your percentage of end mill engagement. And by using pathing like peel milling, you can cut a great big honking slot in a few minutes, versus if you were doing a traditional pocketing style toolpath, you could be looking at over an hour.
Yeah, and when you go back to sort of job shops that were doing this kind of work pre-common CNC work, I mean, I know CNC machines have been around for a while and NC machines have been around for a while, but sort of most job shops before they had access to CNC machinery, they were using something like a big horizontal mill for that kind of work, just because you would need to hog out large amounts of material and and it was the best way of doing it, because if you're trying to do it on a vertical mill manually, it would just take you forever to do.
Absolutely. And a lot of the reason for that is chip overcut is a big issue. So you blow out more tooling from chip overcut than anything else.
Right.
So with a horizontal mill, gravity's going to help pull the chips out of the part and away from where you're cutting. So what happens with chip overcut is you end up wedging the chip between your end mill cutting surface and the sidewall. So not only do you end up with a lousy finished product, you end up with blown out end mills, knackered edges, and things like that significantly decrease your tool life. So they did opt with the universal mills for that kind of operation for heavy slot milling.
And then on top of that, things like tool probing in machines now, we have a much better understanding of tool life and tool wear, and we can actually check tools between parts and whatnot, and be able to figure out how much of a tool wear you're getting. So you can also improve the quality and the life of your tooling just by understanding that kind of thing a lot better. So I've been truly impressed by a lot of that probing inside of machines as they're working.
That's really useful because certain materials, as you know, they machine better than others. Some are a lot harder, and depending on where you get them, you can have problems with consistency in the metal. So you could be machining a batch of pieces, and then all of a sudden you blow out 5 tools because you hit a hard pocket in the material. And I guarantee you, every time that happens, it's all your drills that are gone because your center drill broke, which in turn broke your tap drill, which in turn broke your tap, and then any end mills that came in behind that to do other features may also be blown out because of the stuck out tap.
Yeah.
What a lot of places try and do now is they implement a tool check after a particular tool that's known for breakage is done, so that it doesn't break every other tool after. So what this will do is, depending on the tool length system you're using, whether you're using a Bloom style laser or a Renishaw touch probe, there'll be a macro written in where it'll come in, it'll check the length of the tool, and if it's outside of a specific tolerance, the machine will either alarm out and tell you to change the tool, or if you get really fancy and have a large enough carousel, it will automatically sub in a replacement tool and then leave a message on the screen telling you that the original tool is broken.
Now, on the opposite end of the spectrum, what are some of your least favorite machines to work on, whether at Ottawa U or elsewhere? I heard you mention off show that you're not a big fan of working the Swiss lathes on the line.
No, Swiss turning is something that I've always not particularly struggled with, but I don't like how fast they run. When you're dealing with some of the parts I've dealt with over the years, you're machining some parts with sub half thou tolerancing, and the part cycles are only 58 seconds or less. So, by the time you've found a problem, you've already scrapped another 12 inches of bar stock. So that's one thing I don't really like about Swiss turns.
And then trying to fit your big meat paws into the tiny little space that a lot of those things are working in. You've got 14 tools in a space the size of a playing card, and they're all sitting there, and you're trying to figure out, okay, how do I touch this off and how do I measure that? And it's kind of frustrating dealing with them, setting them up.
Well, not only that, I mean, you've always ragged on me over the years for having my delicate lady fingers over here.
What does that make my fingers?
I don't even know what those are.
Not very useful for me.
The other thing with Swiss turns is because everything's so tight, if you look at my hands, they're covered in scars, and most of them are from Swiss turns from catching another tool when changing an insert right at the back. So you end up catching a part off blade and slicing a great big line in your hand.
Even my own CNC lathe, which is custom built and has a gang tool post on it, the number of times I have slashed my hands trying to get in there and change out drill bits or inserts or whatever, and that I have a pile of space on. I mean, it's cavernous compared to the amount of space that you have in these Swiss machines. So yeah, I can't imagine running those Swiss machines comfortably.
No, I don't like them. I'd rather go to a standard slant bed any day of the week. Slant bed with a turret, that's good enough for me.
I guess there's a reason they call it a gang tool.
That's right.
They do gang up on you.
They certainly do.
Actually, gang tools are gang tool lathes machines I actually do enjoy running. The advantage of those is you can build tooling pallets for specific jobs.
Yeah.
And you can store your offsets online on a USB key. So when you want to run a next job, your setup time is significantly reduced by you already having those offsets ready to input into the machine and just having a pallet you can slot in.
Yeah, I was introduced to gang tool lathes by Dan Simons, a good friend of mine who's a pen maker. Paul, you know Dan, you've met him a couple of times, and he's a old school machinist who had spent a lot of his career building CNC machines for the oil and gas industry, and he built a custom lathe for doing pen work and showed me how he had done it. And the existing lathe that I have is based off of a design that he had shown me. And when he showed me this gang tool setup, and I'm like, oh, all of a sudden the lights went on, and you can start to say, all right, I need these drill bits, these 5 drill bits for this particular style of pen, and I could just drop that on a plate and go, and I didn't have to worry about doing offsets, figuring out and adjusting each one every single time. And it really did, when I was doing a lot higher volume of pen making, it made a huge difference in terms of my production times. I could all of a sudden go from part to part to part very fast, and I didn't have to sit there spending a day struggling with setting up tools.
Well, that's one of the biggest time eaters when you're doing a setup is you're doing your touch offs.
Yeah.
So this is one of the reasons I like automatic tool setters, is because you just build them.
Yeah.
You give the machine an approximate length, and it finds the accurate length for you. So that's what I do like about those. I mean, and gang tool lathes are even faster because you already know the offsets. You set them up once, and every time you set it up after that, the offsets are already known for that particular pallet.
Mm-hmm.
You just have to remember to change it when you blow out a drill and put a new one in.
Yes. Yeah, that can be frustrating.
You've done some incredibly high precision work in the aerospace industry. What sort of factors did you have to take into consideration when you were working at that sort of level?
When you're dealing with precision like that, it's mindful to know what materials you're working with, because once you know that, you can kind of factor in how much your tool might deflect. You can figure out tool deflection on a boring head, but then you also have to factor in things like if you throw too much coolant into that machine to top it off. If you throw 2 5-gallon buckets of coolant in a machine, you're going to move everything out by at least 1/10. And when your tolerance is 1/10 or more, or less, then, too much coolant in at once is going to screw your machine up for the next 5-6 hours. What I used to do in one shop, it's kind of not proud I did it, but I had an IV drip set up, and I would put the bucket high on the table, and I would literally drip feed the coolant. I would have the drip run on its highest setting all night, and it would constantly drip feed the coolant into the machine.
So why are you not proud of this? I think it's kind of an ingenious.
Well, it's not usually easy to get a medical grade IV drip feed.
That's right. Oh, but I mean, you were machining medical grade equipment before moving to aerospace. It's like just a perfect crossover.
Might have been where it come from. All I know is I had it in the toolbox, and that's one thing about a machinist toolbox. They're kind of like a black hole of weird stuff.
Yes.
So every time you work somewhere, you end up buying a new tool for something. And after about 3 or 4 jobs, you open up the toolbox one day and are like, why the bloody hell did I get that? And what did I need it for? But I'm glad I had it that day.
Yeah.
So, yeah, being able to do things like drip feed coolant into a machine. I always found night shift was easier to hold tolerances because nobody would be opening the garage door for deliveries. So you open a garage door for 10 minutes, internal shop temperature drops a few degrees. That might interfere with your machine movement.
Particularly here in Ottawa, where it could be like minus 40 degrees Celsius outside.
Well, when it's minus 40 and the shop's 22 degrees inside and somebody opens that garage door for half an hour, stop your machines, put them in dry run for 2 hours because everything's going to be scrap otherwise.
Mm-hmm. So you've got the temperature, you've got the coolants, you've got the materials in mind. Any other aspects that
Well, you've also got to read your drawings. You need to find out if your tolerances are temperature specific. You could be machining the parts at 22, 23 degrees on a hot shop floor. Your tolerance dictates they need to be corrected to the dimensions at, say, 21 degrees, 22 degrees or lower. And you need to be able to cool those down, get them checked, and verify your machine is good. So a lot of metals will shrink as they cool. So you need to be able to calculate or roughly figure out how much you need to over machine a particularly tight tolerance so that when you shrink the part to temperature, it's bang on size. So that's where an understanding of the material comes in.
Mm-hmm.
And from the conversations we've had, it sounds like temperature is really a huge part of the problem when it comes to precision machining.
Absolutely. Temperature makes a monstrous difference,
Right.
because oils change viscosity at certain temperatures. A few degrees here, a few degrees there could change, your whey oil, could change your hydraulic oils. The casting of the machine can alter. That was the biggest problem when we added too much coolant. You're using frigid cold coolant from an auto mixer. You're throwing that in on a cast iron base. Well, of course that's going to move.
Right.
You're throwing 10, 15 gallons of fresh coolant into a tank that only holds 50. Things are going to move.
So when it comes to actually evaluating and gauging the temperature of the components, what sort of tooling are you using for that, and how are you ensuring that solid piece of metal is actually cooled all the way through when you're taking those measurements?
So what we would do is we'd constantly monitor the coolant temperature using a laser thermometer, the laser probes that they're shooting everyone in the face with when they go into a shop nowadays. So we used to keep one of those at every machine to monitor coolant temperature. We'd also zap the parts and see how hot they were fresh off the machine. And from there, we'd stick them in the QA lab. So the QA lab was a constantly climate-controlled room. We'd put them in there. We'd sit them on the biggest pink granite surface block I'd ever seen. I mean, this thing had to have been 14 inches thick, 6 or 8 feet long, 3 foot wide. It was a monster. I mean, that would suck the heat out of anything. So we knew that through experience and running these parts so much that some parts, you left them on there for 10 minutes, that would have everything out. The really long parts, you'd put them in X amount of time one way and then you'd flip them. So you would get the heat out the other side as well, just to make sure everything was good. And then we'd hit them with the temperature probe before throwing them on either a CMM or doing a manual check. So a lot of it was done with temperature probes and the usual black magic that accompanies machining and metal work.
There was some mention of wire EDM work earlier. How do you find that?
So EDM has actually always fascinated me. Ever since I first learned about it, I was like, wow, it's things like an electric cheese wire. I want to know more about that and how it works. And once I actually finally figured it out, it wasn't that terribly exciting anymore. But it's such an obscure branch of machining. There's not many people around doing it. It's picking up more, and it's always been a common set of machinery to have in die work because you can deal with hard materials. You can buy great big chunks of tool steel that's pre-hardened and just cut through them like it's nothing with an EDM, and you can cut really, really weird shapes with it. And now with the new EDMs that have independent upper and lower heads, you can do transitional pieces. So one of the Mastercam programming exercises for EDM is to make a part using the upper and lower head. When you cut the piece, I actually physically cut one, you end up with a piece of metal that is about 3x3 square, and on the top of the metal is cut a heart that transitions into a maple leaf on the other side. Once I tried that, I was really hooked on EDM then. I'm like, wow, you can do crazy stuff like this with basically a cheese wire.
I had learned a little bit about EDM before you and I met. I had been researching it in the context of cutting pattern bars, but certainly after you and I started chatting about it more, I've gained a lot more respect for what you can do with the wire EDM, and it's one of the very few tools that I don't have in the shop that I would love to have access to, because you can do some truly impressive work with it.
Well, with the nature of what you're doing now as far as work goes with the watches and what have you, you could just throw a great big sheet of metal in there and cut all your bridge plates out. You can blank them all with an EDM. I mean, you're not going to lose as much metal through chipping.
Mm-hmm.
So, you can just set that thing to run overnight and come in the next day and have 10, 15 bridge plates all done.
Which is exactly how things are done in the industry.
Yeah.
And then you've got people like Nicholas Hacko down in Australia actually doing gears on a wire EDM.
Yeah.
Mm-hmm. Yeah. Well, and that's the thing, the tolerances and the fits that you can get, especially the surface finish that you can get on these cuts, is impressive. Mike Walker, who's a legendary knife maker down in Taos, New Mexico, I had an opportunity to visit his shop a couple of years ago when I was down visiting Phil Poirier. And Mike's actually created knives, his zipper series of knives, where he's used an interlocking cut that in two different types of metal, and then he presses them together, and it's just a press fit between the two pieces of metal. So he'll have, let's say, some stainless steel and some Damascus, or some titanium and some Damascus or something like that that are actually put together through this interlocking sort of dovetail cut. And it's really, really impressive, the tolerances that you can get between two parts like that, and be able to press fit them together, and they're never coming back apart, and you will never find a gap in between any of those pieces, which is unbelievable.
So that's the one of the good things about EDM. Most machines nowadays, I mean, whether you're going with a Fanuc RoboCut or a Mitsubishi or even a Sodic, those machines are all repeatable to 5 decimal places on the inch. I mean, they're magnificent, and you, with a bit of experience, you can dial them in even closer using the power settings,
right?
And the finishes that are available through clever power setting, mind blowing. You mentioned the interlocking knife pieces.
Yeah.
There's some fantastic videos on YouTube, so showing guys that have done machining, where what they've done is they've machined interlocking pieces and then run them over with a surface grinder so that the joint is invisible until you pull them apart.
Yeah.
And you'd think it was one chunk of metal because of the brushed pattern from the grinder. And then you just pull them apart. You've got this really weird, complex feature.
Yeah, and the thing that attracts me the most about them, other than the the ability to cut hardened metal and cut intricate shapes, is the fact that surface finish is so good. I can take it to my, I can take a pattern bar off of that wire EDM, throw it into my straight line engine, and I will not see any of the machining marks that are in there, because there are no machining marks in it. And that's for me, that's such a powerful tool.
So that's a huge boon for a lot of people, especially in the dye industry, because any machining marks will be transferred into the piece that you're, cutting with the dye. That's why they use them for injection mold machines and whatever,
right.
Because no machining marks, no impressions in the injection molded piece. The other advantage of EDM is, depending on the wire size, your corner rads are almost minimal. I mean, there's wire now, titanium wire and appropriate size diamond guides down to 2 thou. The only way you could make a 2 thou sharp corner before was to mill the piece to using the corner of the end mill.
Right.
What are some of the challenges or the cons to using a wire EDM that you've encountered?
They are slow as hell.
Yes.
They are incredibly slow. But, the results speak for themselves. I mean, if time's not a factor for you, then EDM is a huge advantage. And they're also the kind of machine that you can just set and forget. So, if you get smart with your fixturing, get smart with your programming, they're the kind of machine that you set to run before you leave the shop, come back with a bunch of parts finished the next day.
But on top of the fact that it's slow, the fact that you are saving a huge amount of cleanup work, and you don't have to worry about doing any deburring, you don't have to worry about doing any finishing afterwards. So they're not fast. They're certainly not as fast as the high-speed milling that you can do these days. But at the same time, you still end up with a part that you do not need to process afterwards, and that has huge implications. You don't need to heat treat it and worry about the part deforming because you've now heated it and whatnot. So yeah, you can save yourself a significant amount of time, even though the machine itself is not very fast.
The other thing with EDMs is they don't generate any cutting force. So on parts that might have stress issues from other machining, you don't get features potato chipping on you. So that's when a part starts to warp when the edges get thin. There's no cutting force generated during the cut, which is also having a positive impact on the machine itself. So you're not wearing out features anywhere near as fast. I mean, the EDM we have at U Ottawa is an old Japax. And when I ran the serial numbers on it, that machine was built in 82. And it's still running as accurate. I mean, it's definitely bloody filthy now compared to when it was new, but it's running parts just as good and just as accurate as it did in day one.
Well, and that wire is a consumable, so that's really the only that and the dielectric fluid that you're using in it is really those are your consumables right there.
Well, dielectric fluid in wire EDMs nowadays is just deionized water.
Oh, perfect.
So we're not using, it's not like the dirty old days of EDM where you'd have an EDM fire because, you'd run out of dielectric oil, so you were subbing in kerosene.
Right.
And then you'd end up with an EDM flash, which would, blow up the town.
Yeah.
But no, most wire EDMs now are just using dielectric water. I have to fill mine with deionized water.
Well, and a lot of the machines these days will actually deionize the water for you.
That's right.
They've got filter systems in them, and where you just dump in tap water and they'll spit out deionized water for you.
They do handle it themselves, but there is a time period that you have to cycle the pump for.
Right.
So if you let your tank get half empty and then you half fill it with tap water, your resistivity is going to go all over the place, and that'll impact your cut significantly. So what you have to do is cycle the pump for an hour or so to get all that water run through the deionizing bag.
And then one of the challenges with old wire EDMs that's been overcome now is that you do have to feed that wire into the from one holder to another, and if you want to try and cut an internal feature, then you needed to drill a hole and then manually feed that wire from one to the other. But a lot of the new machines can actually do that themselves, can't they?
So a lot of new machines run they do have an auto feed.
Yeah.
So the auto feed feature is very handy, especially if you get a breakage during cut. So what will happen during cut is the machine will jog over to its initial start point, rethread the wire, wrap it back into where it broke, and then finish up the cut. If you're doing internal features, you always need a start hole.
Right.
With the EDM, a wire EDM cannot create its own start hole unless it comes in from the side, which, what's the point in that? You may as well not add a start hole at all.
Right.
So, most parts you do have to do an initial, more conventional machining process. Like if you're making something where you've got a plate with a big square in the middle, put a start hole offset from the corner, and then you just have it come in. That's your indication point, and cut your square.
But that's relatively easy to do, and that's the sort of thing that you could do quickly on any number of vertical machining centers, and be able to pop in the holes that you need, and then fixture that up on your wire EDM, and then you leave it run overnight, and you come back and you've got a bunch of parts sitting there that are cut out.
So the other thing with EDM is you can do edge detection on the machine. So you actually use the wire as its own edge finder.
Right.
So you can locate the part and set your G54 positioning right on the machine using the wire. There's no locating with special tools or edge finders. You literally just run an indication program built into the machine. And that can either be probing the center of a hole using 4 points. You can probe an edge. You can probe the other edge to get the corner of a part. And then what you do is you set your upper jet height and your lower jet height. Depending on what you're doing, the ideal gap between upper jet and lower jet is 8 thou above the part, 8 to 10 thou. So what that does is it forces I don't want to call them chips because it's basically sludge that comes out. So this forces the sludge through the cut. So what happens is it's kind of like getting graphite powder in electrics. It starts arcing against itself when you have too much sludge in the cut, and that will affect your surface finish, or you'll start getting overburn and other features like that, which can negatively impact a part's final purpose.
Now, for anyone listening who thinks we've been talking about electronic dance music these past few minutes, what is EDM?
So EDM is electric discharge machining. So you're using electric discharge to vaporize metal from a workpiece and trace your pattern. Think of it as TIG welding without a filler rod. Your brass wire is electrode 1 and your workpiece is electrode 2, and it's energized during that gap. And when you bring the two together, you make an arc. And because there's no filler rod, the arc comes away from the workpiece and vaporizes that material and leaves a gap.
For people who are more familiar with woodworking technology, this is very similar to using something like a bandsaw or a scroll saw, where you can cut complex shapes and sort of get around and do a lot of work that you wouldn't be able to do, let's say, with a straight saw. But in this case, you're just doing it at a very, very fine level with metal, and you're discharging it. or you're using an electrical discharge to cut it.
That's an excellent way to put it, actually. It's an electric bandsaw or a fancy bandsaw. That is the most apt way to describe it. I mean, I use the term electric cheese wire because it's the brass wire that we use is 10 thou. So that's 0.25 millimeter for you metric people.
Now, on a drilling note, I actually watched, don't ask me why, a Japanese game show where they were drilling out a piece of 0.5 mil pencil lead, and they pitted an EDM machinist against a traditional machinist. And the EDM machinist was actually plunging a charge down into the piece of graphite. So it is also possible to drill using EDM technology. It would not be at all efficient or feasible in the same way to sort of pair that with this type of machining where you've got the upper and then the lower head. So it is much better just to drill the hole out first for doing any sort of internal cutting.
So the other technology you were just referring to with the graphite pencil lead versus, the two different types of machinists, that's a different EDM technology called die sink. So die sink is where it's a similar principle, but you're burning, your upper head has an electrode in it, which it can be either made of graphite or copper. And what that does is it uses a series of rapid up and down motions to burn material away. So if you've got a particularly tight square you want to burn into something because you have a block that goes in, you can literally run in with a die sink and burn out the hole with sharp corners and not have to do any post-processing whatsoever.
Or complex shapes, you can do
even complex shapes.
Some pretty impressive die work with a die sink EDM, and as long as you can machine that electrode to the shape that you want, you can actually sink it straight into a piece of carbide if you wanted to. Something there's no way you'd ever be able to cut otherwise. It's pretty impressive.
That's why they're so common in mold shops, because you can machine an external copy of a particularly fancy geometric shape and just burn it into a piece of tool steel, and there's your mold. So the advantages of that are you can work with pre-hardened materials. You're not having to go through the process of rough or semi-finished machining, heat treating, annealing, and then finishing the mold and blowing out tons of carbide or what have you. You can literally just machine it into a soft material like copper or graphite, burn it into pre-hardened material, and send it out the door.
Have you done any sort of work in mold making?
I haven't done mold making myself, but I have used plenty of die sinks, and anybody who's worked with EDMs before is going to understand this one entirely. One of the most common uses for die sink is burning out broken taps.
I was going to say, you can actually buy sort of quote-unquote inexpensive sinker EDMs that are sold specifically for the purpose of burning out broken taps from parts.
Actually, what I like to do is, because our die sink at Uotawa is an old clunker, and I think it belongs, melted down and made into something more useful. What I do with a broken tap, if it's large enough, I will feed the wire down between the flutes, and then I will run a cross section and then run a circle. And then I literally just take the tweezers and pull the 4 pieces of broken tap out.
I was going to say, that's probably more effective than a lot of these sinker EDMs are. That's great.
So if you need a tap burning out, but it has to be a through hole.
Yes.
It doesn't work in a blind hole.
No, that's problematic.
You hinted at having a bit of disdain for 3D printers.
You're used to working on reverse 3D printers all the time. Why are you complaining about them?
I'm just an old-fashioned chap who likes carving metal the old-fashioned way. And the biggest ball ache I've had with 3D printers is ever since the advent of them, everyone and his brother's been telling me or asking me, am I frightened a 3D printer's going to take my job away? I'm like, not a chance. And as soon as I got to Uotawa, what have I been doing? Building new parts for printers. So the printer's bloody brilliant until you need a machinist to get it fixed for you.
Well, the right 3D printer, you can just machine, you can print your own parts for it.
Yeah, but, when you're using them knackered old filament type ones, the brass head gets all choked up. And then you go to the manufacturer asking for a new part, and, they're wanting $60, $80 for what's essentially a $3 brass bit.
Yeah. Yeah, 3D printing technology is certainly interesting, and and it has a place. I find the filament printing is not particularly interesting. Some of the new sintering technologies that are out there for directly printing into metals are certainly fascinating. When David Fletcher gave me a tour of Cookson's Gold a couple of years ago, he was showing me their 3D sintering machine, and they were printing directly into platinum, and that was amazing watching that thing. There's certainly some impressive work that you can do with that. You still have finishing problems, which is one of the biggest issues with 3D printing. Is the surface finish is just not good enough for for a lot of things. But there are other technologies now. There's laser polishing technologies that are actually helping to solve a lot of those finish problems that are coming out of the sintering printers as well. So some of that work is certainly interesting. But as with every machine, a lot of this stuff is complementary. It's there are machines now that are hybrid machines where they're doing some 3D printing of metals, and then they're coming back in and machining those features partway through the 3D printing, so they can actually get to internal surfaces with the traditional milling machine, and then once they're finished machining that surface, then they can continue 3D printing and then make that surface unavailable again. So there are some interesting ways that you can use the two of them together, but like most things, it's complementary. It's not going to be a replacement technology for anything.
So you were mentioning the hybrid type machines. So I forget the name of the company off the top of my head, but it was in a Modern Machine Shop a couple of years ago, and it was a milling head that went into the standard tool spindle.
Oh, right.
And what it was doing was it was coming in and it was printing lugs onto the side of a bar, and then coming in and machining those lugs and adding tap features.
Right.
And the reason they were doing that was because it had to be basically one solid piece, and they were wasting hours and hours roughing a great big round bar to get these little 1/4 inch lugs on. So they said, well, what if we tried this? And they used a smaller bar, printed the lugs on, and then machined them as usual. So what that did was it cut around 4 hours of roughing time out of a part.
And material wastage
Material
as well.
wastage, and even the amount of money you save just on carbide alone.
Sure.
By not having to rough a part out for 4 hours.
Mm-hmm. And just to paint a picture for listeners, provided I'm thinking of the same machine you're describing, you actually have a print head that is being put into a traditional CNC machine, and into that is being fed essentially a stream of powdered material. So usually in sintered 3D printing, you're laying down layers of the material and then running a laser over that to harden it, and then you basically have this block of powder that slowly grows up. Then you eliminate all that powder and you're left with your 3D printed part. But rather than do that, they're essentially firing a stream of the material through the head of this, almost call it like a fixture for that is being put into the CNC machine. And there's also a laser on it that is sintering that material as it's blasting out of the head. And it is a really fascinating synthesis or synergy of these two technologies. And there just simply are things that are impossible to create any other way than through this technology. So that is a really neat part of the market I'm interested to see grow and evolve and expand.
See, that's the kind of technology you want to see being used in turbine repair, where you can literally throw a piece back in a machine, locate the fin, fill in that region with the laser sinterer, and then come in with your ball nose end mill and machine that area nice and flush again. That would save significant amounts of environmental waste on trying to rebuild that entire turbine fan from scratch using virgin material. So you're going to basically be repairing the turbine as opposed to remanufacturing it. I think that's kind of where we need to go in the manufacturing world going forward, because the amount of planet ragging that's going on, just looking for new carbide alone, new tungsten to find carbide. I mean, that's Sandvik has an amazing carbide reclamation program going on where they offer you significant cost savings on carbide when you send in your knackered old tooling, because they pulverize it, grade it, and then resinter into new tooling. Sandvik has been significantly trying to cut down its reliance on virgin tungsten for tooling, They're trying to do most of their new insert manufacture via reclaimed inserts and end mills.
That's really heartening to hear.
Yeah. The other thing we'll put a link to is, which is interesting, is Adam Booth, who runs a YouTube channel, ABOM79. He's done a lot of job shop machining, and he sort of got his fame in the YouTube world because he works on some really, really large parts. Like he was doing drive shafts for large windmills and things like that, if I remember correctly. But these massive drive shafts that are, a couple of feet in diameter. But one of the things that he's done that I've seen a couple of times is he's actually spray welded onto shaft, because there's sometimes you end up with a groove on the shaft and you can't remachine the material because you don't have enough there. So he'll spray weld onto the existing part while it's on the lathe. So he'll slowly turn it on the lathe, spray weld it, and build up that material again, and then he'll come back in afterwards and turn it back down to the nominal dimensions that it needs to be. So it's same kind of idea. Now he's just manually doing it and adding material back on, but it's great watching that sort of work as well, because again you're dealing with these massive pieces of metal, and there's the cost of scrapping these parts just because a small portion of it needs to be remachined is ridiculous.
Absolutely.
That's something we've had to do from time to time as well when refinishing watch cases. Even the odd watch part, like putting a new hook inside of an old barrel for restoration service. It's actually using the laser that our jewelers use to laser weld and building up some material in a void or where something has broken off, and then remachining that area. Yeah, it is just really, it's a neat way to work. Certainly doing it manually is not nearly as fast or precise as some of these new machines can do things. For restoration and repair work, there really is no other way to go.
Yeah.
Now, in the vein of restoration and repairs, you built quite a name for yourself working on old pens.
Yeah, so they tell me. I kind of take on the jobs that nobody else wants to touch, because some parts might require remanufacturing because, the parts are no longer available. Some of the pens that I've dealt with, fantastically old, and anybody that has parts for these doesn't want to get rid of them because they themselves might need them one day. One particular part being the helix drive shaft in a safety pen. So these things are notoriously fragile. They were fragile in the beginning, and now you add a century of age onto that old ebonite. These things have a tendency to crack, and then they don't drive anymore. Through my own experiences with manufacturing over the years and what I've learned mathematically, I've been able to offer reproduction safety pen spirals now, which is a huge, huge deal for guys in the vintage pen community.
Now, what is ebonite? If I were to guess, I would imagine it's some sort of form of plastic that's trying to replicate ebony.
Originally it was, yes. It was it's a black vulcanized rubber plastic. It also goes by the name vulcanite or car tires. But it's essentially a heavily sulfurated vulcanized rubber. So it becomes an exceptionally hard rubber compound, which can then be turned and machined and made into pens.
Nasty stuff when you're a jeweler and you like having silver around, because the sulfur in it, as it's off gassing, tends to blacken all of your silver, because it hastens the silver oxide transition that's happening there.
I've actually noticed through my own working with vintage ebonite, because a huge focus of my own personal vintage pen collection is ebonite. I love French ebonite pens. They had the best color patterns. And I've noticed that the vintage ebonite is significantly harder than new ebonite. I'm sure there was some really nasty stuff went into that vintage ebonite that makes it as beautiful as it is.
Well, it's also had 100 years to finish doing any curing that it was going to do, right? That's one of the other problems of modern ebonite, is that people tend to put it out to market too fast, and it hasn't actually finished its curing process, and it hasn't finished off gassing, which is problematic.
That's particularly problematic with celluloid.
Yeah.
Celluloid is a brutal one for improper curing. Anybody that's into OMAS pens, especially the green colors, you'll probably notice over time that some of the ends are starting to turn violently green. So what that is, it's celluloid deterioration. And that is the plasticizing agents off-gassing from the ends of the pen. And then, of course, the crazing starts because the plasticizers are no longer there. And that off-gas will actually spread within other pens in that pen tray. So it's always very important, if you're into celluloid, to vent your pens to get rid of that off-gas. Pretty sure the vintage pens were nitrated cellulose. So you basically have nitric acid off-gas.
Coronavirus of celluloid pens.
Basically, well, and it's funny because different communities call it different things. So in the fountain pen community, we just call it degradation or crazing. And then you get to the straight razor community where it's called cell rot. So the celluloid, they believe it's rotting away, which that nitric acid off-gas does a terrible, terrible thing to the beautiful steel blades in those things.
Now, some of these old materials are interesting when you deal with them. Everything from casein to bakelite to celluloid and whatnot. I've worked with some of these materials to make pens over the years, and they present interesting machining challenges, but they're also incredibly problematic later on because a lot of these materials are not very stable. We're used to modern plastics, which for the most part are very stable, and while they will do things like discolor and whatnot over time, especially due to UV, they tend to be pretty stable once you've worked with them. The modern acrylics that I use, the cast acrylics are great. They're nice and stable. But some of these older materials can be very problematic if you're not careful with them.
Casein, you mentioned. That's a really funny one. Casein has its own set of problems because, just like a gremlin, you can't get it wet.
Yeah.
It's a mixture of milk protein and formaldehyde. And what happens with casein is when you get it wet, it basically turns back into milk. These pens, I've seen horror stories where people have put them into soak overnight, a vintage pen to clean it, and then they've come back in the morning and all they've got is the metal hardware left and this tub of awful looking yogurt. Casein was particularly popular over in Europe, and England really took casein to heart. They made everything from buttons to pens with it. Conway Stewart was a huge consumer of casein back in the 40s and 50s. They love the stuff. It also goes by the trade names of Milkstone and Galalith. So anybody that sees Galalith rods for sale, it's basically casein.
Yeah, you can find a lot of that for sale on eBay if you want to find vintage rod stock. I troll eBay occasionally for vintage celluloid, and that's far more challenging to find. And but the Galalith, once you try turning that the first couple of times, you understand why you don't want to keep turning it, and that's why it stays available on eBay for very long periods of time because he's just waiting for the next sucker to come along and buy more rods of it. But it's nasty stuff to turn as well. Like it's not pleasant. Frankly, none of those materials are very pleasant to turn. I remember the first time I turned a bunch of pens out of ebonite, and we were speaking about thermal expansion earlier, and drilling out the ebonite and then tapping it. Well, it as it heats up, it expands quite a bit, and so I went off and I drilled and tapped all these pen barrels, and then came back and I couldn't figure out why my sections weren't actually screwing into the pen barrels, and it's because all of those threads had shrunk by so much that they were no longer usable with the threads that I had cut on the other side of the the section. So I had to go back in and actually manually tap all of those holes again afterwards. It was incredibly frustrating, but it was a good lesson in the challenges of dealing with some of these weird materials, and then of course the smell of turning some of these materials is not particularly pleasant either.
No. The ebonite smells like the legendary Springfield tire fire.
Oh yeah, yeah.
So you can have a lot of fun with celluloid if you know enough about the material. A fun thing to do is save the chips because the chips are extremely flammable. You should always clean out the chip pan on a lathe after you've finished machining celluloid and are going back to metal, because the hot chips from the metal may start a minor conflagration in your chip pan.
Yes.
I mean, if anybody remembers all those camera film fires in Hollywood in the glory days of cinema. That was all celluloid film just exploding.
Well, there were actually laws passed in the States that would prevent people from transporting celluloid film canisters on public transport because it was so dangerous, because they used to just have these canisters of film that they'd be bringing to the cinema, and they were like, nope, can't get on the bus with that because they were just too dangerous.
Going back to vintage, in the realms of repair, a common adhesive used back then was shellac. So, to glue section joints together and stop things falling apart. The problem with that is celluloid has a tendency to explode at around 150, and shellac doesn't let go till about 125, 130. So you have a very small window between exploding the pen and getting the pieces apart. So that does present some challenges.
I can imagine. You gotta get that beetle poop off there somehow.
That's it.
Don't try taking apart any of my celluloid pens then, because I use Loctite on that stuff, and the Loctite doesn't give way until about 400 degrees.
You're using the red or the blue?
At that point, it doesn't really matter. It's still well above the temperature of the celluloid.
I think it's retaining compound.
Yeah, exactly. Now, speaking of safety pens earlier, you've actually been working on your own safety pen as well over the last year or so, right?
That's right. I built a safety pen from scratch.
Oh.
I've been a big fan of safety pens ever since I first heard about them. And I have 14 or 15 of my own vintage ones. But I'm terribly careful about transporting them around because it's century-old ebonite.
Yeah.
And, all the mechanics are good in them. I don't want to use them needlessly. So I decided to build my own, just so that I had a user-grade safety pen. So I got a nice vintage nib and feed out of an old knackered pen and decided to use SolidWorks and design an entire safety pen. And then I built a prototype.
Mm-hmm.
And it proved so popular on Instagram that I'm probably going to shove that into production using a shop in town.
Yeah, I have to say I'm happy that somebody is producing a modern safety pen, because the number of people that used to come up to me on a regular basis at pen shows, oh, you're making custom pens. You really need to make safety pens. I'm like, I have zero interest in making safety pens. They're an absolute nightmare. So I'm glad that there's somebody who's crazier than I am who has decided to actually make a modern safety pen. I know Dan had made one or two, but I don't think he ever sold any significant numbers of them. But it's nice that you're talking about making them, because there is a small subset of the community that's as I said, crazy enough to actually want these things.
Well, I think what's going on with the pen community now is the community is so saturated with what I call Yovo sticks. So those are your basic Yovo number 5, number 6 pens, cartridge converter. So the variety of those is so huge now that I think when I put the safety pen out, it was just like something so new and unique that it was like extremely popular. So I still get plenty of messages asking me when it's going to be available.
Yeah, it is difficult to distinguish yourself in the pen world unless you're doing something particularly interesting with the sort of the casing around those nibs, because everybody, now you can get really good quality nibs from Yovo, and they're amazing nibs, and they're not problematic. Their feeds are great. So that bit is no longer a distinguishing factor amongst pens. And, anybody with a lathe can sit down and turn a pen quite easily, and with a little bit of experience can turn something that's, that's not half bad. So it is difficult to sort of distinguish yourself amongst the sort of that lower and middle grade pen that's out there. And that's one of the reasons why I never went into that market. I always went into higher end pen markets with, sort of jewelry grade pens with interesting finishes on them and interesting sort of designs, because there are just so many people making a plastic pen that's sort of in that sub $500 range, and it is sort of tough to distinguish yourself in that crowd.
So for the record, I don't actually hate Yovo nibs. I think they're the best can nib that's out there.
Oh, yeah.
I just call the pens Yovo sticks because anybody who's making a custom pen these days is using Yovo, and it's for a damn good reason.
Yeah.
They make the most trouble-free canned nib available, and my safety pen's probably going to be launched with Yovo nibs, I'll be honest with you.
Yeah.
Because I know I'm not going to have any grief with them.
No, exactly. Over the years, I played with a bunch of different nibs from different companies, and all of them gave me trouble in one way or another. Especially the feeds were miserable. Or a lot of times the tipping material on the nibs was inconsistent. A lot of them were soft, and you end up with problems with them. So yeah, the Ovo nibs I've always been pleased with, and it's definitely the way to go if you're going to be making new ones.
On the other brand canned nib units, the biggest issue I've been encountering is alignment. Tip alignment is huge. I mean, it plays a huge role in how smooth a pen is and how it performs and how the ink is delivered to the page. And if the alignment's off, the pen's going to feel scratchy and miserable. And thanks to YouTube, anybody can now buy a pack of mesh pads off Amazon and start hacking away at that nib, not realizing that all you got to do is bring it back into alignment. So I always tell people that, 95% of the nib work that I've done over the years has been just alignments. I literally sit at a pen show and align nibs for 8 hours. That's I very rarely have to touch the sandpaper. It has to be a very special case for me to bust out the stones and the micro mesh pads, because you just take a look at the nib and you can feel it with your eyes that it's out of whack. That's kind of a shrouded warning to stay away from the micro mesh until you've checked the alignment.
Yeah, a lot of people have become sort of amateur pen modifiers over the last couple of years, and there are even some of the people that are professional pen modifiers now are not much better than the amateurs that are out there. So if you're going to be sending your pen off to somebody to be repaired or to have the nib adjusted, do a little bit of research and make sure the people you're sending it to actually have a clue about what they're doing. In my case, I've had Mike Masuyama do all of my nib work over the years because he's an incredible nib grinder and has done some spectacular work for me over the years. I've got a particularly nice sharp italic nib that you could shave with. It's so sharp, and it's lovely to work with for myself. But he's done some amazing work for me, everything from needles to just fixing general problems with nibs. But it is certainly difficult to find somebody who's good at doing nib work. So if you have a fountain pen and it needs to be repaired, be careful about who it is that you send it to.
Yeah, I can't say good things about Masuyama. I mean, Michael is just, what he doesn't know about nibs isn't worth knowing.
Yeah,
to be honest.
Exactly.
If Mike doesn't know about it, you don't need to know about it either.
Yeah.
It's superfluous information.
Yeah.
So in what ways did your work on vintage safety pens, or even your own collection that you've amassed of vintage safety pens, inform your design choices for the safety pen that you designed?
It informed and influenced my design of the safety pen quite heavily. There was three major, I guess, safety pen countries of manufacture back in the golden age of the safety pen. You had the Americans, which were basically Waterman. I mean, there's a couple of Wall Eversharp safeties out there as well, but they're so insurmountably rare. I'll never see one in person. And then you had the French. The French safety pens, they were actually popular until probably around the 50s. The safety pen finally died out in France. And then the Germans. And the German safety pens are constructed so very differently from the others that they almost need a special education on their own in safety pen construction to get them apart without busting them to pieces. I like the French ones because I really enjoy the cap to barrel proportions when they're closed. The cap is a little bit longer on the French style versus the American style Watermans. And that influenced my design quite heavily. So when I thought about dimensioning my pen, I went through my entire collection. And what I did was I dug out a few pens that were my personal favorites. I found out exactly what I liked about each individual one and tried to incorporate that in my design. I really enjoy the length of the Meisterstück number 149 when it's unposted. It's a perfect pen length for me. So I focused on making my extended safety pen as long as a 149. The only problem that comes with that is the pen can't now be too skinny. If it's too skinny, it's going to look ridiculous. I found another pen I like the diameter of. I settled with the M600 from Pelikan, the Souverain M600. And I took the diameter of that and also an M800. And I settled on somewhere in between being the ideal number to fit the length of a 149. And then I took an Aurora Optima, best pen ever made in my opinion. I love the extra long section and taper profile of the Aurora Optima. So I made my grip end of a safety pen with the same taper angle as the Optima. So I've incorporated 3 different modern pen design elements and dimensions into one pen, and I've made to my hand what feels like my most perfect pen. Once I get a few of these out in the wild, I'm sure somebody's going to say it's too wide, it's too long, the grip section's terrible, it's too long and tapered. And this is kind of the feedback I want.
But at the same time, everybody's hand is different, and what works for one person isn't necessarily going to work for another. It's impossible to make a single pen design that's going to make everybody happy. That's certainly something that I had a challenge with, and you need to at some point realize that you're not going to be able to. You have to make something that's intentional and that you're happy with. You know, my pens have been relatively heavy. I've made sure that they're well balanced so that they're easy to write with, but they're still heavy. They're larger in diameter than a lot of modern pens as well. So, but again, that's for me because I've had a difficult time finding pens that were comfortable for me to write with. And, so that don't be too quick to take other people's advice on changing what you find works well with that pen. If, you might want to make a second pen that is a larger pen or a smaller pen than what it is. But just remember that that not everyone is going to be happy with that pen for various reasons, especially for size. And that's something that I certainly struggled with for a long time.
Yeah, I'm going to tend to agree with you on that one. You're not going to be able to please everyone. And to be honest, not everybody's going to want to buy this pen.
Sure.
What kind of pushed me towards making a safety pen is the amount of people I see eyedroppering their pens. And eyedroppering is, if you're not into pens, eyedroppering is when you remove the cartridge converter system and you pour ink into the open barrel, put some sealant on the threads for the section and screw it back together. So you've gone from 0.2 milliliters of ink to maybe 6 or 8 milliliters of ink in a barrel. And the amount of people I see eyedroppering kind of made me think, what if there was a purpose-built eyedropper where you don't have to screw anything back together, you don't need to put your own thread sealant in, you literally just retract the nib, pour ink in the hole, extend it, and you're good to write.
Mm-hmm.
As for dimensioning, like we spoke of earlier on sizes, some are going to moan that it's too big, some will moan it's too small, but I'm sort of restricted on dimensioning because of the mechanics involved in this pen.
Mm. So what were some of the challenges you encountered in designing out those mechanics?
There wasn't really too many challenges, to be honest, because it's a design that's been done before. All I did was kind of add a minor perfection to the wheel. I've gone from a rear crosspin style assembly like the Waterman's, and I've gone with an internal crosspin to pull everything together, which gives me an invisible join across the top. So with the Waterman pens, you can see the shaft and you can see the crosspin wedging everything together. I was never a big fan of that. It should be seamless. So I did some fiddling around and I made it a seamless joint on the back and naturally replaced the more traditional cork seal with modern fluoroelastomer O-rings, which means people shouldn't have to be pulling it apart very often.
And did you have a singular material in mind when you actually machined it, or did you experiment with a number of different materials for your pen?
For my prototype, I just used a basic black acrylic. There's a bright orange ring on the cap, which kind of started as a complete accident. As Chris knows full well, it's a nightmare to design a pen clip.
Yeah.
It is one of the hardest parts, and it will make or break a pen. A bad clip will just either make it a smash hit or ruin everything. So I needed a spacer to take the place of a clip washer so I could test my fit and finish. So I made this orange ebonite ring, threw it in, and that's proven one of the most popular design aspects of the entire pen was just this little orange ebonite ring against a sea of black resin.
Yeah.
Now the pen's going to be clipless.
No, don't tell me that, Paul.
Yeah.
No, there's too many lazy pen designers in the world who don't put a clip on their pen.
You know what? I could do an accommodation clip. I might have some casting work for you.
We can no longer talk, I'm afraid. Sorry. I was willing to tolerate your Mont Blanc pen obsession, but clipless pens, I can't abide by that.
Well, traditionally a safety pen was clipless anyway, and I'm trying to channel the vintage vibe.
Uh-huh.
I mean, I don't want to make another Mont Blanc Bohème or Heritage 1912.
Yeah.
You know, those are safety pens to an extent. And, one of them's a cartridge filler and the other one's a built-in piston / captured converter. The problem with those is, they're a nightmare to clean.
Yes.
Mine is not terribly difficult to clean. You literally just fill it with water and shake it over the sink. And
Right.
The two of you seem to have a number of differences in your opinions and approach to pens. I was surprised to note that you're into the Mont Blancs.
Well, he has, he even talked about the Optima as being the best pen that, created, but he has the best pen that's been created. He has one of my Model 8 pens, which is clearly the best pen that's been created. It's perfectly balanced. It's incredible to write with, and it's a gorgeous piece of metalwork as well. It's got this beautiful engine turned cap on it. So I'm truly disappointed in him saying that the Optima was a nicer pen than that.
Your Model 8, for me, would be the best pen ever made if it held more than a teardrop's worth of ink.
Oh, please.
Since I've become kind of a supervisory figure in the machine shop at U Ottawa, I'm using my pens a lot more and I'm driving through a lot more ink than I used to. And I love my 08. I think it's a magnificent piece, but I don't want to eyedropper it and I want more ink in it. Maybe I can request you to build me a piston filler.
All right, maybe I'll figure out building a piston version of that pen for you. Although that'll really mess with the balance of it, so I'll have to figure that out again.
Well, I mean, I can fix it for you. I can drill a slot in the side of it and put a lever in.
No. Oh, please don't do that. I hate lever fell pens. Those things are horrible.
So, what is it about the Mont Blancs that has drawn you to acquire as many as you have?
I'm going to be honest with you. Chris told me not to buy Mont Blancs. Chris told me not to buy Mont Blancs. All you're getting is an overpriced plastic pen. And you know what? To an extent, I do agree with him. But if you've held a Mont Blanc, they have a feel about them. And it's the feel of the pen that really gets me about Mont Blanc. And I like the page standoff, especially on the 149. The nib is a paving slab of 18 karat gold, and I like the page standoff with the 149. And to be honest, Mont Blanc is one of the last few companies doing its own nibs, and they are also offering sizes outside of your standard fine, medium, broad. So, for Mont Blanc to continue offering those more outlandish nib sizes, I like chunky nibs, and I have a 146 triple broad oblique, which is a very rare nib to get. They don't even make a triple broad 146 oblique anymore. So I have one of the last ones from the 80s. And, when a company's still making nibs like that in-house, that speaks a lot to me.
Yeah, so there are a couple of Japanese companies that are still making their own nibs. Sailor's doing it. Yeah, and that's one of the big things that I push when people are looking at pens is that you need to buy from a company that's producing a good quality pen and that know what's going on with their nib. That is really the heart of the pen itself. No matter what the wrapper looks like or feels like, if the pen is not writing properly because the nib is miserable or the feed is miserable, it really doesn't matter how nice the pen is. It's just not going to be pleasant to write with. I have some pens that are absolutely gorgeous that I love the look of, and I will never ever write with them because they have miserable nibs on them. Find a pen from a company that's actually making decent nibs themselves. That's one of the first things that I tell people when they're going out and finding them. At least if you're buying something commercial. Obviously, finding something from an independent maker, that's a different story. But find somebody who's using a Yovo nib. That's the easiest way to find a pen that will write properly in the independent world. But from the large commercial ones, somebody like a Pilot or a Mont Blanc. They're still doing good work on their own nibs.
So do you have any thoughts on Mont Blanc's handwriting analysis system and that sort of custom nib fitting recommendation engine that they have?
So the Mont Blanc bespoke nib service, where you go into the dealer and you do the writing analysis on the pad and it picks up all the pressure points and stuff. That's a very, very expensive service. And it's probably not something I would ever go for unless it was to get the, it's basically an 18 karat gold spade. It's like I guess you could call it a music nib because it has, it's wider than it is long.
Yeah.
I mean, it has to be like a quad broad or larger. And it has 2 slits to make sure it can feed the ink down to that wide of a tip. That's probably the only way I would ever go with the Mont Blanc bespoke service.
And honestly, at that point, I would talk to somebody like Mike Masuyama, who is, again, he's an expert nib grinder. He will grind you a nib for significantly less money than you're going to pay for that service. And it will be a perfect nib if you talk to him about what it is that you're looking for, or any of the other high-end nib grinders. You talk to them about what it is that you're looking for, and they will take your favorite pen. Doesn't have to be a Mont Blanc, it can be anything, and they will turn it into something that you will absolutely love to write with. And honestly, every single pen that I write with on a regular basis all have custom nibs, and they've all been nibs that I've sat down with Mike. This is where, unfortunately, in these times with COVID, we can't have pen shows, but if you have a pen show in your area that you can go to, and most of the major metropolitan areas in the U.S. have a pen show. A lot of them in Europe have pen shows as well. And there are often nib grinders at these shows. Go down and sit down with them and say, look, this is what I'm looking for. This is the pen that I've got. And they'll help tune it to you or your hand and your handwriting. And they'll do it for, $100 US. Whereas, this service from Mont Blanc, you're paying dramatically more than that for that service.
For the bespoke nib service, for a standard nib to get that thing ground up, yeah, no, it wouldn't be worth the effort for me. I would literally just go and sit down with Michael Masuyama, and I know it's going to be spot on, no matter what pen I put in front of him.
Yeah,
it could be a $5 Pilot Pereira, or it could be a $1,000 Mont Blanc, and anything in between. Anything you give him is going to be on point every time.
And in terms of balance and that writing feel that you spoke about, that you do appreciate about the Mont Blancs, and of course Silverhand Studios number 8. What sort of considerations did you put into the balance and adjustment of that balance when you were making your pen?
Naturally, you want a fountain pen to be slightly tip forward. If it's back heavy, you end up constantly fighting against the back weight, trying to keep the nib forced down, and that becomes a very tiring experience very quickly. It's actually one of the things I enjoy the most about Chris's pen. It's the most balanced pen I've ever written with. I mean, write with one finger, and I know it's going to run great. But with regards to my pen, I did make considerations with regards to trying to keep the weight forward, which is kind of easy to do when you're putting, I think my pen holds around 3.5 to 4 milliliters of ink. So when you've got a pen that's got that much ink in it, it's very easy to tip the weight forward. It kind of does it itself just through gravity alone.
I was going to say, until the pen starts to run dry, it's got quite a bit of mass in it just from that ink running forward.
And I did take that into consideration when I was doing my I did SolidWorks simulations on the pen, and that was kind of interesting to see, because the advantage with that is you can see if the mechanism would generate enough pressure to actually spurt ink out when you extended it. It was kind of interesting to see it work first time. After it, first design, it worked beautifully.
Now, is there a certain viscosity then, at which point your pen design would spurt ink out?
Well, I would imagine if you put Vactra number 2 whey oil in it, you'd have some grief. But most water-based inks are consistency of water.
Well, thank you for joining us here on Off Hours today to chat, Paul. I really appreciate it. Is there anything else you'd like to share with our audience before we wrap things up?
I suppose a word of warning with the micromesh. don't do it till you're lined up, because I'm tired of getting nibs with flat feet on them.
Where can people find you online, Paul?
Instagram's the usual spot.
Yeah.
Machinist_Paul. That's where you'll find me floating about. Basically, all you're going to see there is machined pieces I've done at work, pens, and maybe some of the dogs.
Thanks for listening to Off Hours. You can find detailed show notes at offhours.show. If you'd like to keep up to date with the show, follow us on Twitter @offhours. John can be found on Twitter @UnderTheLoop, and Chris can be found on Twitter and Instagram @silver_hand.